Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Mr. Imthiyaz Ahmed, your Managerial Statistics lecturer. I would like to welcome our dear students to understand and solve problems in normal distribution, estimation, and hypothesis testing. Today, I have divided my discussion into 8 parts, cited with ProQuest references for further reading. First, let us see practical problems on how to deal with z-values normal distribution. Let us see a problem. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the variance is 2 pounds. If a household is selected at random, find the probability of its generating more than 30.2 pounds per month. Now we need to assume the variable is approximately normally distributed. Step 1, we need to write down the values given in the question. First, our population mean is 28 pounds as I move the pointer, and our x is 30.2 pounds given in the problem, and our variance is 2 pounds. This is also given in the problem. So first, let find the z values. The formula for z value is equal to, that is, z is equal to value minus mean divided by standard deviation. Our value given in the problem is 30.2, mean is 28, divided by standard deviation is 2. It will give you the result 1.1. If you draw a diagram of normal distribution, our z is equal to 1.1 comes on the right side. As you can see, I'm indicating with the arrow. So it is coming on the right side, it means positive. Step number 2, normal curve to the right, z is equal to 1.1, that is our answer what we arrived. We need to find table value for z is equal to 1.1. So when you find the table value, you will be getting 0.3643. So as usual, when it says normal curve to the right, you need to reduce 0.5 minus the calculated Z1 value, that is 0.3643. So when you multiply into 100, we will get a result 13.57%. Hence, the probability that a randomly selected household will accumulate more than 30.2 pounds of newspapers is 13.57%. So I hope this problem with regard to Z values is clear. Let's move on to the second part to understand what is estimation and hypothesis testing. First, let us understand what is estimation. It is a specific numerical value, or it is also said estimate of a parameter. The best point estimate of the population mean, as it is indicated by the symbol, is the sample mean. These statistics are called the estimators. There are three properties of good estimator. The first one is unbiased estimator. The mean of the estimate will be equal to the parameter being estimated. Consistent estimator is regarded as a sample size increase. The value of the estimator approaches the value of the parameter estimated. Efficient estimator is considered the relatively efficient estimator has the smallest variation. So I hope meaning with regard to estimation is clear. Next, let us understand what is hypothesis testing. A statistical hypothesis is a conjecture about a population parameter. It may or may not be true. There are two types of statistical hypotheses for each situation. One we call as null hypothesis, that is, it is regarded symbolically as H naught, as I'm indicating by mouse H naught. Number two, it is called alternative hypothesis. It is regarded as H1. Further, with regards to hypothesis testing, drawing a wrong conclusion is called an error of inference. This type of inferential error, rejecting the null hypothesis when it is true, is called type 1 error. Usually, this rejection is called alpha. There is also another type of error in statistical inference. This error occurs when the null hypothesis is false and the empirical results do not lead to its rejection. This error is called type 2 error and its probability is called beta. What are the points to be kept in mind while solving estimation and hypothesis testing related problem? For 90% confidence interval, Z alpha by 2 will be equal to 1.65. 95% confidence interval Z alpha by 2 will be 1.96. 99% Z alpha by 2 will be 2.58. So these are the points, students, you have to very carefully consider and keep in mind before solving a problem. Let's see a practical problem with regard to confidence intervals. So let me read the problem for you so that you can understand very clearly. The president of a large university wishes to estimate the average age of the students presently enrolled. From past studies, the standard deviation is known to be 2 years. A sample of 50 students is selected and the mean is found to be 23.2 years. Find the 95% confidence interval of the population mean. So this is the problem. What is a point to be kept in mind? I told you, whenever the confidence level is stated, either it is 90 or 95 or 99, we need to remember what is Z alpha by 2. In this problem, for 95%, we need to write, since 95% confidence interval is desired, Z alpha by 2 is 1.96. As you can see, it is 1.96, and after that we need to use formula for solving this problem. Now, hence substituting the formula for this will be mean minus Z alpha by 2 multiplied by standard deviation divided by square root of n. As you can see, the other part, sample mean, will be mean plus Z alpha by 2 multiplied by standard deviation divided by square root of n. One side it is minus, the other side is plus. So students, if you remember one, the other one will be very easy to remember. So after substituting the values in the formula, that is our mean is 23.2 given in the problem, and Z alpha by 2, as we know, 95% confidence level is 1.96. Our variance is given 2 years and square root of n sample is 50. So if you know one side, the other side is the same, only you need to use plus. So step number 1, you need to take 2 divided by the square root value of 50, then you need to multiply 1.96. The answer will be 0.55. So in one end you need to reduce, in the other end you need to plus. So once you reduce, the answer will be 22.65 and 23.75. Therefore, hence the president can say with 95% confidence that the average age of the students is between 22.65 and 23.75 years based on 50 students. So how I am telling is the final answer after using the formula. What we derive is we need to mention and write the comments. So this is the problem with regard to 95% confidence interval of the population mean. So let us solve the same problem with 90% confidence interval of the population mean. So with 90%, when we say 90%, the Z alpha by 2 will be 1.65. So by using the same formula, our result here, it will come to 22.73 and 23.67. So you can write a comment. Hence, the president can say with 90% confidence that the average age of students is between 22.73 and 23.67 years based on 50 students. So this is the answer for 90% confidence interval of the population mean. I hope this part is clear. Let us understand for 99%, the same problem. I will show you the result for 99% confidence interval of the population mean. So when we say 99%, Z alpha by 2 is going to be 2.58%. This you have to keep it in mind. So substituting in the formula, our result will be 22.47 and 23.93. Therefore, we can say that hence the president can say with 99% confidence that the average age of the students is between 22.47 and 23.93 based on 50 students. So I hope with 3 confidence interval the same problem I have solved. Finally, with this, our normal distribution, estimation and hypothesis testing with regards to chapter 7 is over. If you have any comments or queries, you can email me. I hope you enjoyed my video. Thanks for watching.